Assalamu alaikum. Good evening to all. Everyone thinks that this signals and system subject is somewhat difficult, but it is somewhat easy subject, general subject. Every E and C, triple E, instrumentation people should know these subjects very well because this is one of the best subject, core subject in GATE syllabus also. Basically, what is a signal? Definition of a signal. Signal means signal. Signal. Everyone of us know signal. We have already heard this so many times. This basically your phone network, what you will see in your Android mobiles and all, which will show the network. That is also one of the signal. Means signal is one which conveys information. Let us go into the definition of signal. A signal can be defined as a function of one or more independent variable which conveys information of something, for some information. Okay, it is what is basically signal. I will give a best example for a signal. Let us consider a cricket match. Let us consider a cricket match in which let us draw a graph. As you all know, when you are watching cricket matches, they will show some graphs. These are also signals. Let us consider in x-axis as overs, overs, and this is the score, 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 score. Sorry, I can't write this very legibly, but you can understand. Okay, let us consider this as first over, second over, and up to let us consider this as 2020 match, 20 overs. This is the score. In first over, he hit some 6 runs in first over. In second over, some 3 runs, 3 runs in second over, 3 runs in second over, and in fifth over, some 16 run. Like this. If you join these all, you will get some graph. This is basically one of a signal. Okay. Let us now get into deeper. What is signal? Okay. Another example for a signal is your voice. Voice amplitude, the voice amplitude versus the time axis. That is the graph for your voice. Let us consider this. This is a x-axis, time, and this is your amplitude of your voice, amplitude of your voice. Okay, when you speak, your pitch is high, like this. Some voice. This is voice signal. This is also one of a example for signal. Okay, Another example, best example is image signal. Image is also one of a signal. Image means, let us consider this as x-axis, this is y-axis. If you write something, if you draw something like this, this is image signal. Means, let us consider a function I is equal to x comma y. This is function of this image. Means it has some x value and some y value, and they are joined together to form a image. This is example for a signal. Signal can be not only be 1D, means one dimensional. It can be two dimensional also. It can be three dimensional also. Let us know why we are studying this subject. Why we have to study this subject? Basically, you are all communication, electrical and instrumentation guys. You should know how to transmit signals from one place to another place. So we have to know what are the signal processing steps, how signal is processed and transferred. Basically, if you want to transmit a signal, the main criteria is bandwidth. Bandwidth means, if you draw a signal can be not only be, it can only be time axis in x direction, it can be frequency also. If you consider it, the x-axis as frequency, and in y-axis you consider magnitude, then if you draw some signal, if you draw some signal if you draw some signal from this point to this point, the frequency which is there, this is called bandwidth. You know bandwidth, you have heard bandwidth, where in internet and all we will say my internet bandwidth is more. If the bandwidth is more, the signal information is more, but the transfer means, the what transportation means, the sending of these signals is very difficult. That's why that's why we consider, we will, what we'll do, we'll compress the signal, means we will reduce the bandwidth of signal, then we will transmit the signal. Let us I will tell you some basic about how signal is what signal processing, what are the signals processing steps and all. Signal processing steps, okay. First, signal processing processing steps steps okay, sorry, steps, you know, steps, signal processing steps, okay. Signal processing steps. First is enhancing. enhancing. Don't go into this deeper. This is higher, but you, why you are studying, you should know. Then you will get interest in this subject. Enhancing means extract. Enhancing means achieving the signal, means drawing the drawing the signal characteristics, means plotting the signal in x and y direction, and capturing an image like this. These are all called enhancing. Extracting means, second is extracting. Extracting means, if you consider any, have you ever seen, everyone know that ECG. If you see ECG, not every point is important in ECG. Let us draw ECG signal. You know this type. You have already seen this signal like this. Heart for heart checkup. Not every point in this signal is important. That's why we will consider some point, and extract this signal, and we will see what is happening, because to study about the disease, ECG is about heart, that's why extracting is the second. And then next, after extracting, what you have to do last, next you have to store the signal. Store. Where you will store it in memory cards, hard disk and all. Because why you have to store? To get the information afterwards also. That's why you have to store the signal. Next, after, last is, if you want to, if you want clarity in signal, means if you want the signal in some band limited, means you have, if the signal has the bandwidth, means frequency is very high. If signal frequency is, let us consider 10 kilohertz, if you want only 5 kilohertz signal, then what you will do? Then just simply you should filter it. That's why signal processing, filtering is the last step. These are the basic steps in signal processing. After that, if you want to transmit the signal, then you have to compress the signal, and you should uh, transmit the signals. Okay, these are basic about the signals, uh, what signal processing steps and all. Let us now start the signal, original signals. What a subject will start from this. Types of signals. There are basically, signals can be considered in two types. First one, first is the first is the analog signal or continuous signal. Continu Signal, continuous signal. These are also called are analog signals. Analog signals. These are real-time signals. I means I have already given all these are the example. All last time, which I have given the examples. All these are example for the continuous time signals. Now, the first I have written, no, already I have written that is first one is continuous time signal, and the second one is the discrete signal. Discrete means discrete, in the world it is there, no. Discrete means what? Divided means made into discrete parts. Okay, discrete signals, DIS, discrete signals. Okay, discrete signals. This is the type 2 signals. Let us now go into details of this signal. Continuous time signal. Continuous time signal means, here, continuous time or analog signals, these are real time signals. You already know DC, DC, direct current. What is that? It is time, time axis with respect to voltage. Here the voltage is constant, some 5 volts, like that, 5 volts, 5 volts. This is an example for a continuous time signal. Continuous time signal, DC. DC signal is basically a continuous time signal. Another example I will tell you for this analog signal. You have already know, this is time axis, this is time axis, and this is amplitude. Consider it as amplitude, like this. This is what? Exponentially decaying signal, e power minus at. This is a exponentially decreasing signal. This is also an example of signal. And anyhow, these are standard signals which I have drawn previously. If you draw something like this also, something like this, or something which time axis and amplitude, these are all called analog or continuous time signals. Okay, next, discrete time signal. Discrete time signal means nothing, it is same only. If you draw signal like this, some signal like this signal, time signal, this is voltage axis, let us consider. If you pass this signal, through a switch, means switch, let us consider this as switch. Yes, if you pass this signal as switch, as when you pass this signal, when switch closes, then only the signal passes. Means if you open and close switch intervally, means by some constant gap, then you will get the discrete time signal. That is what the discrete means. This continuous time signal is passed through the switch. This switch is basically called as sampler. I will come to you it later. First, let us, if you pass this with constant what gap, intervally, time intervally, if you will change this what switch, open and close the switch, then you will get this signal, this discretized signal. This is called basically discrete time signal. Any not only this signal, earlier I have drawn no exponentially decaying signal. Let us consider this is exponentially decaying signal. If you pass this signal also with constant, if you close and open the switch constantly, then you will get this signal like this, like this. Okay, this is called basically the conversion from discrete, you can get the signal, continuous time signal into discrete time. You can get discrete time signals. Okay, now In this lecture, I will end up this lecture by giving you some standard signals which are used in this what signals and system. Standard signals which are used in signals. First basic signal is unit step function. Unit step step function. Unit step function, you can say unit step signal. This is signal, no? Signal. Unit step signal. Okay. Unit step signal. This signal, how you will represent, means how you will write it mathematically. It is indicated by u, small u of t. Means it is a signal which has x-axis, that is time, with respect to time. Unit step. Unit means, unit, what unit represent? Unit means unit represent one. Step represent what? Step, staircase step, like that. What is the definition of the signal? U of t is equal to, this is the definition of signal. Okay, u of t is equal to 1. It is 1 for t greater than equal to 0. Means if t is greater than equal to 0, time axis is greater than equal to 0, the amplitude axis is 1, constant 1. If it is, if the signal is, time is less than 0, then the, no, means amplitude is 0. Let us draw this signal, then you will get to know. This is time axis t, and this is amplitude. Let us indicate this as u of t, amplitude as. Then if you draw unit step signal, this is like this. Means how? Means the amplitude is constant, that is 1 up to infinity, and it is starting from 0. Look at this. What is this? Means this t greater than equal to 0 is equal to 0, it is 1. The signal is starting from 0 and it is it is constant. If it is thus, if the time is less than 0, the amplitude is 0. This represents the unit step signal. This is very important signal, you should remember. If you want to note it. It is very important. You can get it this from every signals textbook. Okay. Next, very important signal, but in real time I will tell you. This is time axis. This is amplitude, amplitude. And I have not tell you about this signal, no. Okay, I will tell you the impulse signal. Unit, you can't say unit impulse function. This is second standard signal. Impulse signal. Okay, impulse signal. This is represented by delta of t. As you have already studied in physics and all about the impulse. What is impulse? Impulse is a small, it is a very large force applied for very small time. This is what in signals, what we will say is if you consider this zero means if you apply a signal which has an infinite amplitude infinite amplitude for very small duration, then this is called impulse function. This signal in real time does not exist, but for characterizing the systems and all, we will use this signal. You will get to know afterwards. Okay. uh, Now I will tell you unit impulse function. Basically we will not tell this as impulse function. We will use this as unit impulse function. Means unit means unit means already means it has amplitude 1 at 0, that is delta of t. How you will write it mathematically? Delta of t is equal to signal means what? It is 1. Amplitude is 1 at what? When t is equal to 0, and when it is 0 when t is not equal to 0. This is basically the definition of unit impulse function. Okay. Now let us consider another standard signal, that is the rectangular signal, or you can say gate function. You can also say rectangular signal. Third is rectangular. I am writing in short form, rectangular signal. Okay. Rectangular signal, how it is represented? It is represented as a rect. A means this represents the amplitude, and this rect represent the rectangular function, and this t divided by big T means it is indicating the width of the rectangular signal. Okay, let us draw this signal. Rectangular signal means this is the time axis, and this, if you write it as t, amplitude is a only, but if you represent this as t here, you have to represent it as t by 2 here, and minus t by 2 here. Okay, let us stop here the discussion. Thank you.